Hi, I'm Miss Solrig, and in this video I'm going to teach you how to find x or y values given either the x or the y or the domain and range in the function. So in this video we're going to be evaluating how to find given x or y values when you're presented with a certain variable, either the x or the y. So you're always going to be given an equation for a function. In this one, our equation is y equals negative x plus 3. Well, first of all, understand that this is a negative 1x technically that we have in the problem, and it gives us the point. It says if 4y is a solution to this equation, determine the value of the y. So remember, in a coordinate, you always have an x and a y value, and what they've given here is the x. So they're telling us that the x is 4, and they're asking us to find the y. We don't know the y. So what we're going to do is we're going to take this 4 here, and we're going to plug it in for the x value here. So I'm going to rewrite this equation as y equals negative 1 times 4 and then plus 3. So when we start to solve this, we're going to have y equals negative 1 times 4 is going to give me a negative 4, and negative 4 plus 3 is going to leave me with a negative 1. So that means my solution to this would be a y equals negative 1. I could also write this back as a point like I started with. When the x was 4, the y is negative 1. So this would be the solution here. For number 2, we're going to do the same thing. It says if x10 is a solution to the equation y equals 3x minus 2, determine the value of the x. So this time our equation is y equals 3x minus 2. And remember, I'm always given an x and a y value. So here they give me the point x 10. That means that my y is equal to 10, and I'm being asked to find my x value. So I don't know that yet. So what I'm going to do is I'm going to take this 10 here, and I'm going to replace the y with that 10. So I'm going to rewrite this as 10 equals 3x minus 2. Well, since that x is in the middle of the problem, I'm going to solve this by moving everything away from that x. So I'm going to start by adding 2 to both sides. So this will cancel. 10 plus 2 gives me 12. So I have 12 equals 3x. And then finally I'm going to divide both sides by that 3. So this gives me a final answer of x equals 4. Or I can put it back in a point, and if I know that when the x is 4, the y is 10. So this would be the solution for number 2. Alright, same concept on number 3. It says if x negative 4 is a solution to the equation y equals negative 1/4 x plus 3, determine the value of the x. So this time here's my equation, my function, negative 1/4 x plus 3, and I'm given the values x and negative 4. So that means then my y is equal to negative 4, and again I don't know my x value. So in order to solve this, I'm going to have to take this y here of negative 4 and plug it in where that y value is. So I'm going to say negative 4 is equal to negative 1/4 x plus 3. And again, because I'm solving for that x value, I'm going to start by moving everything away, beginning with that negative 3. So I'm going to say 3 minus 3 cancels. Negative 4 minus 3 is a negative 7. And then we have negative 7 equals negative 1/4 x. So finally, to solve for the x, I'm going to divide both sides by a negative 1/4, which remember when we divide by a negative, that's like saying negative 7 over 1 times 4 over negative 1. That fraction flips when we're dividing fractions. So this is going to give me a final answer of 28 is equal to x. Or I could write it back as a point. The x is 28 and the y is negative 4. So this would be my solution for number 3. Alright, number 4, it says if x negative 4 is the solution to the equation 4x minus 5y equals 8, determine the value of x. So this time my expression, my function, is 4x minus 5y equals 8. And they gave me the point x negative 4. So that means that y here is equal to negative 4. And again, I don't know my x value, so that's the unknown. So I'm going to take this y here of negative 4, and I'm going to change it in this problem where that y is. So I'm going to say 4x minus 5, and instead of y, I'm going to write negative 4. And that will equal 8. So to solve on this one, I do have to solve for the x. First thing I can do is multiply what's in my parentheses. So I have negative 5 times negative 4, which is a positive 20, and that will still equal 8. And now I can move everything away from the x. I'm going to start by subtracting that 20 from both sides. So we'll have 4x equals negative 12. And then finally divide both sides by that 4. So this would give me x equals negative 3. And again, if I want to put that in a point, then I would have the x is negative 3 and the y is negative 4. So this would be my solution for this equation. Alright, this time it tells us to determine the range of the function f of x equals 3x minus 5 when the domain is negative 4, 2, and 9. Essentially what we're doing here is three separate equations. First of all, I have this one equation, f of x equals 3x minus 5. First of all, remember f of x is the same thing as a y. It means the same thing. So anytime I have f of x or anything on that side of the equation, it's just a y. Now this time what it asks for, it's asking us to find the range or the y values when the domain, the x values, are negative 4, 2, and 9. So essentially these are all x's and will be replaced in this problem where the x value is. So I'm going to do three separate equations for this. The first equation, I'm going to plug in a negative 4 where that x is. So I'm going to have f of negative 4, because I'm plugging that in for the x, equals 3 times negative 4 and then minus 5. So to solve here, the f of negative 4, we would multiply 3 times negative 4, that gives me a negative 12, and then negative 12 minus 5 would give me a final answer of negative 17. So again, this just represents the y, so I have y equals negative 17. That's the first solution. So again on this one, I'm going to plug in the second number, which is a 2, into my expression. So I'm finding f of 2 is equal to 3, and instead of that x, I'm going to replace it with a 2 minus 5. So we have f of 2 equals 3 times 2, which is 6, and then 6 minus 5, which is going to give me 1. So again, f of 2, that just represents the y. So we know that y is equal to 1. So that's the second solution for this. Okay, the third solution is to plug in the 9. So we're going to say this time f of 9 is equal to 3 times the 9 minus 5. So here for f of 9, we're finding 3 times 9, which is 27, and 27 minus 5, which gives me a final answer of 22. So again, f of 9, this is just y, so y equals 22. Now remember, I had three solutions to this. I had negative 17, 1, and 22. So this is my range. These are my y values when the domain is this, and we write our range values by plugging it into parentheses and writing it in order from least to greatest, which it is. So this would be my final answer to solving for the range. So again on this one, it tells us to determine the range. Those are the y values of the function f of x equals x squared minus 8 when the domain, the x values are negative 4, negative 3, and negative 1. So essentially these are all x's that we'll be plugging into this equation. So for this one, I'm going to start with f of negative 4. So I'm going to say f of negative 4, that's my first x value, is equal to, and here I'm going to plug in that negative 4 for the x. So I'm going to say negative 4 squared minus 8. So for this one, I'm going to start by my exponent. So I'm going to say negative 4 squared would be a positive 16. And then 16 minus 8 is going to give me 8. So this one, again, remember, is just equal to y. So y equals 8 is my first solution here. Okay, we're going to do the same thing with the second point, which is at negative 3 for the domain. So we're going to say f of negative 3 is equal to, and I'm going to replace that x with, again, negative 3. So we have negative 3 squared minus 8. So for this one, again, we start with our exponents. We're going to say negative 3 squared is a positive 9, and 9 minus 8 is going to give me a positive 1. So this is going to give me a solution of y equals 1. Okay, we're going to do the same thing on the last one. So we're going to replace the x now with a negative 1. So I'm going to find f of negative 1, and I'm going to say, instead of the x, negative 1 squared minus 8. So for this one, again, we start with our exponents. So we say negative 1 squared is a positive 1, and then positive 1 minus 8 is going to give me a negative 7. So this is going to give me y equals negative 7. So this is our last solution. And to put it all together, we're going to go ahead and write our range out. So our range on this one from least to greatest, remember, we write it in brackets here, and that would be negative 7, 1, and 8. So this would be our range for this problem here. All right, for this one it asks us to determine the domain. So it's asking us for the x values for this function, f of x equals 2x plus 1, when the range, when the y values are negative 3, 9, and 15. So remember, this f of x here, f of x is the same thing as y. So what it's asking me to do is take these values and plug it in where I see that f of x, or the y. So I'm going to rewrite this one this time as, instead of the f of x, I'm going to plug in negative 3, which is equal to 2x plus 1. And we have to solve this one by moving everything away from the x. So we're going to start by moving that 1 over. Negative 1 minus 3 is a negative 4. So we have negative 4 equals 2x. And then I'm going to divide both sides by that 2. So this gives me a solution of x equals negative 2. That's my first value for the domain. Okay, the second number I'm going to plug in for this f of x, this y here, is going to be 9. So I'm going to say 9 is equal to 2x plus 1. And again, we have to solve for the x by moving everything away. So I'm going to start by subtracting that 1 there. So this is going to be 9 minus 1, which is going to give me 8. And then 8 equals 2x. So we're going to solve to divide both sides by 2. That gives me a solution of x equals 4. So that's my second number in my domain. Okay, the last number I'm going to be plugging in for the f of x, or the y, is that 15. So we're going to say 15 equals 2x plus 1. And again, we're going to subtract the 1 first. So it gives me 15 minus 1 is 14. 14 equals 2x. And then to solve, I'm going to divide both sides by 2. So this gives me 7 equals x here. So I have 3 solutions for the domain on this one. And again, we write domain from smallest to largest. And we are going to write it in those brackets to show that it's a set. So from smallest to largest, our domain is negative 2, 4, and 7. This would be our final answer for the domain on number 7. All right, last one, it asks us to determine the domain. So again, these are the x values of the function f of x equals 4x plus 9 when the range, again, those are the y values, are 5, 21, and 33. So these numbers are going to get plugged in where that f of x is, because remember, f of x is the same thing as y. So we're going to start with 5. So I'm going to say 5 is equal to 4x plus 9. And again, we have to solve this by moving everything away from the x. So we're going to start by subtracting that 9 there. So 5 minus 9 is going to give me negative 4. So I have negative 4 equals 4x. And then I'll divide both sides by that 4 there. So this is going to give me x equals negative 1 as our first solution for the domain. Okay, the second value I'm going to plug in for the f of x, or the y, is going to be that 21. So I'm going to start with 21 is equal to 4x plus 9. And again, solve the same way. We're going to subtract 9 from both sides first. So 21 minus 9 is going to give me 12. So I have 12 equals 4x. And then to solve and divide both sides by that 4. So we have for a second answer for the x value of 3. So x is equal to 3. Okay, and then finally we're going to be plugging in that 33 for the f of x there. So we're going to say 33 is equal to 4x plus 9. And solve the same way. We're going to subtract 9 from both sides to begin with. This is going to give me 24 is equal to 4x. And then I'll divide both sides by that 4. So this will give me 6 is equal to x. Now to write the final answer for the domain here, the domain again we write from smallest to largest, and we're going to write it in those brackets to show it is a set. The smallest number was -1, followed by 3, followed by 6. So this would be our domain for this function. So I hope that helped you to understand how to find either the x or the y in a given equation, or to find the domain and range. Remember, we just plug in any values and solve for the other. So keep watching for more videos, and remember, ask questions in class to get further clarification. I'll see you next time.